Hello and welcome to my fifth hand-in, which is about 5 functions for sorting, and most importantly it should be made so everyone can include it, meaning that I've created another source file and a header file, and I guess that's the most important aspect of this assignment, so that's what I'm gonna focus the most on. First of all, this is what we've normally worked with, our main source file, and so far we've just created functions, for example outside of the main, and we've just run it inside the main, or even created the function inside the main. And so this, I guess, is what the user, if we suppose that a user should just be able to include our file and run the functions. This is supposedly what he have. The user can create an array, and yeah, here I'm just printing the array. That's pretty straightforward. No real explanation needed, and I'm printing it again down here. And he should just be able to call the function with the name of the array given. I also explained it in here. I guess you can just pause it and read it if you want. Yeah, so the user can just call, for example, bubble sort function, insertion function, selection sort, quick sort, and binary tree sort, all those functions, and the array given will be sorted. Yeah, for example, this is bubble sort. We have the array unsorted, and it's sorted. And I guess I can just try and call something else. So let me try binary tree sort function, and it works. And I'm not gonna use that much time on bubble sort, insertion sort, and selection sort because they're pretty similar. It's just a basic swap that's done in each of them. So I'm gonna try my best and explain quick sort and binary tree sort and the basic concept of how this is made. So first of all, what I had most trouble with was building the two source files, which you choose in here for both debug and release. You have to include what files you will be building, and I struggled with that for God knows how many hours, and I solved it by having my array inside my main instead of my header file. So of course it's always the easy solution. And yeah, my header file is what the user should include in your main, and inside I have my struct and I have the functions. Of course not the body of the function, but what's called just a prototype. And I have an integer called size, which is 10, and I use that for several loops, and is the size of the array. Yeah, so I guess the user shouldn't really mess around with the header file and the other source file, so I guess that's a good thing if you want to include it. In here we have all the functions. So when I build and run and it sees this line, for example bubble sort, it checks where it is, and it finds it in this source file, and it basically just jumps into this line and runs this function. So as I said before, it's pretty straightforward. It's just a double for loop, and it checks if your array, which is for example in this case j, which starts up with 1, is smaller than 1 minus 0, which is then 0, and it is, and it just swaps them, and it just minus I every time, so you don't have to go through the entire array, because there will always be one list to sort every time you run through this for loop. And this swap, as I guess we were supposed to make it, didn't work for some odd reason. I don't know, I tried a lot of different approaches, but it should work, but it didn't, so I just cheated a bit on this, I had to. And yeah, the insertion sort function is basically built around the same principle with the swap function, just different inputs and a different approach to it. And the same for selection sort, pretty straightforward again with a temporary which saves the array and it swaps it. Yeah, the quicksort is explained through, and it's a recursive function, so you have, first we have a function called partition, which basically chooses a pivot from the array, and then it checks if all the elements which is smaller than the pivot is moved before the pivot, and all the elements which is greater than the pivot is moved after. And then this function actually runs the partition function. So you only have to write quicksort and it will run your partition. Yeah, and this, as we can see, it's just a while loop and it always moves. Oh, and I should mention we have a variable called p and r, and we input this as, of course, we use my array, and we have 0 and 9. So of course that's because our array is 10 and the first element is 0 and the last is 9, and just moves p upwards and r downwards. So and that will pretty much, and again it's built around the swap, so again that's pretty straightforward. And it returns r, and then it runs this function, which actually runs this. I hope that explained it. It's a bit difficult to explain, but the principle behind quicksort is pretty easy. And then we have the binary tree sort, and again, like the quicksort, it's how it sorts is pretty easy to grasp, but the actual code for it is somewhat more difficult to explain. So I'll try my best. First of all, it's built around a struct, which most importantly have the left and right, a pointer to left and right. And of course we use this as we know it. We always choose, for example, the first element in an array to be the root, and then we move the smaller elements to the left and the greater to the right. And so we always need to make, for example, a new node, which is basically what this function does. It builds the binary tree for us. So for example, if this is null, we build a left. For example, we go down to left and build again a left, and then a right, which is null, and we can insert values to this. So basically just builds the tree for us. And of course the design is the same. If, for example, we imagine we have a root here, left, right, we go right, And now this is the new parent, and it needs 2 new children, so it goes left and right again. And you can just go on. This is new parent and new child, and so on. And of course the only one who don't have a parent is the root. Yeah, I hope that explained the principle behind the binary tree well enough. And this just fills in the elements of the array into the respective positions. And down here we have what I mentioned before. We have the root, which left and right is set to null, and the root is set to the first element in the array, which in my example were, for example, 6. And when we check the next element, which is 7, it will move that to the right of 6, and then 8 again to the right of 7, so we have 6, 7, 8, and then we have 1, so that will of course be on the left. And here we actually we first run the build tree. So when we run this function inside main, it creates the root, and it makes the build tree, root, and then the array, which loops with I, which is of course like a normal counter, which just counts 1, 2, 3, 4, and so on. And again it fills it. Yeah, I hope I explained it well enough. The actual code is somewhat difficult to explain, but what happens with, for example, the binary tree is actually pretty simple to grasp. Yeah, that's it.